So good morning children. So last class we have discussed up to relative density. Okay. So last class we have discussed up to relative density. So what is mean by density? So density is nothing but what? Mass divided by volume. Mass divided by volume. So what is the unit of mass? Kg per meter cube, or suppose we may use the small object instead of kg, gram. Okay, so gram per centimeter cube, gram per centimeter cube. Okay, these two are the units of what? SI units of density. So what is the symbol of density? Rho. What is the symbol of density? Rho. So next one, what is mean by relative density? So relative density is nothing but, okay, comparison between two substances. So one is the given substance, another one is we have to take as what ma? Water is a standard one. Okay, so here we have to mention the temperature. Why? Because of temperature, liquid it may be extant. Okay, so the temperature is important. Okay, so relative density. Okay, what is the short form of relative density ma? RD. Okay, so density of the substance divided by density of water at 4 degree Celsius. Density of water at 4 degree Celsius. Okay, so why we want to take the temperature at 4 degrees Celsius? Because of, okay, at 4 degrees Celsius the density of water 1 gram per centimeter cube, 1 gram per centimeter cube, so almost equal to 1. Okay, so almost equal to 1. So with the help of relative density we can find out their masses also. Okay, so this much informations we have discussed last class. Okay, so today we are going to start the next topic. Okay, so how to measure the relative density? So measurement of relative density, so with the help of picnometer, okay, or density bottle. Okay, what is the other name of this one ma? Density bottle. Density bottle. Okay, so with the help of picnometer, or otherwise is known as what ma? Density bottle. Okay, we have to measure the relative density. So how to measure the relative density we will see. So it is made up of glass bottle. Okay, so here one small hole is given. We have to close with the help of what ma? Closer, tap. Okay, here we have to insert the thermometer. Okay, this is called what ma? Thermometer. Okay, this is called lead. Okay, so we have to fill with the what? Water. Okay, we have to fill with the water. Okay, it is made up of glass materials. Okay, we have to fill with water. We have to keep in the refrigerator. Why? We have to bring the temperature at what degree Celsius? 4 degree Celsius. Okay, so ordinary temperature we have to fill with water. Okay, again we may keep in the refrigerator. What will happen? Okay, again we will get the gap here. Why? Okay, because of temperature it may reduce. Okay, the expansion of liquid also decreases, so the volume it may be reduced. So again we have to fill with water. Again we have to keep in back refrigerator. So what is the help of this one? What is the help of this one? Suppose excess of liquid, what will happen? It will come outside. Okay, so exactly the temperature, okay, exactly thermometer showing the 4 degrees Celsius, we have to measure the weight of the entire picnometer. Okay, it may be W2. Okay, before that we have to put the weight of the empty bottle, W1. So exactly we have to take the weight at what degree Celsius? 4 degree Celsius. So after taking the reading we have to substitute in which formula? So relative density is equal to density of the substance divided by density of water at 4 degree Celsius. Suppose if we take the reference substance as water, Okay, so instead of relative density, we may use what ma? Specific gravity. That word also we can use. Okay, so in this way we may find out the value of what? Relative density. Okay, so next one, floating and sinking. Floating and sinking. Float or sink. So what is the meaning about float or sink? Okay, so if you are taking one vessel, okay, you have to fill with the water. You have to fill with the water. Okay, so we may take two objects. One is wood, another one is iron ball. Another one is iron ball. Okay, so simultaneously we have to put it into where? Into the beaker. What will happen? Okay, so which object it will float on the surface of the water, which object or which material it will go down. Okay, which object ma? Iron ball, it will go down. Okay, wood, it may be float on the surface of the water. Why? Because of weight. Because of what ma? Weight. So here weight is nothing but what ma? Density. Here weight is nothing but what? Density. So which object or which material contains more weight than water? More weight than water. Automatically what will happen ma? It will sink in the water. It will sink in the water. So which object or which material contains less weight when compared to the given amount of the water? What will happen? It will float on the surface. It will float on the surface. So can you understand ma? What is mean by float? What is mean by sink? So based on this, what principle? Density principle. So which object containing less density, it will float. Okay, less density. So which object containing more density, it will sink in the water. Okay, so can you understand ma? What is mean by float and what is mean by sink? Okay, so next one. So based on this floating principle, okay, one of the instrument is working. So without taking the measuring bottle, directly we can measure the readings. Okay, applications of principle of flotation. Applications of principle of flotation. Applications of principle of what ma? Flotations. Okay, first one, hydrometer. First one, hydrometer. So what is mean by hydrometer? Okay, a direct reading instrument. A direct reading instrument used for measuring the density of the given liquid. Okay, direct measurement, density or relative density. So with the help of what ma? This meter. Which meter? Hydrometer. Okay, so we may take that meter, we may immerse into the liquid. Okay, so no need to put weight or no need to do any calculations. Okay, directly we can measure the what ma? Density or relative density. That is the advantages of what ma? When compared to picrometer and this one. Which one? Hydrometer. So picrometer we may take, we have to put the weight, next we have to do the calculation, everything. But hydrometer, no need to do the calculation. Okay, direct, like digital. Okay. So hydrometer is based on what principle is used ma? Principle of flotations. So what principle is used in the hydrometer? Flotations. Okay. So the weight of the liquid displaced in the where? Jar. Okay, that is equal to weight of the hydrometer. Okay, suppose if you are taking glass jar filled with water, okay, so we may insert the hydrometer. Okay, definitely it will displace the some quantity of water, some amount of water. Okay, that amount of water, suppose 5 gram of water is coming outside. Okay, that 5 gram is nothing but what? That is the weight of the hydrometer. That is the weight of the hydrometer. Okay, can you understood? Okay, hydrometer is the directly used to measure the density or relative density. Second point, it is works on the principle of what ma? Flotation's principle. Third one, how much amount of the water is coming outside when we may immerse into the hydrometer into the liquid. That liquid weight is equal to weight of the hydrometer. Okay, next we will see the construction of the hydrometer. So we have to take the glass jar. So this is called what ma? Hydrometer. Here we have to fill with what? Water. Here contain mercury or lead. Okay, lead balls, small balls. Okay, so it consists of what ma? Hydrometer consists of a cylindrical stem having a spherical bulb, at its bottom side. Okay, cylindrical stem having a spherical bulb where? And it's the lower end, okay, and a narrow tube, okay, and a narrow tube where? Upper end, okay, narrow tube upper end, down where what ma? Spherical bulb. Okay, this portion is called spherical bulb. Here narrow tube. Okay, so after setting this apparatus, we have to take the hydrometer. We have to immerse slowly. Okay, how to, when we have to hold up this hydrometer when it is floating where? In the liquid freely. So up to we have to hold up. So after removing the hand, it will float freely where? On the liquid. So next we have to measure the reading. Okay, so up to which the water is touching the hydrometer. Okay, suppose the water level is touching here. Okay, this is the reading of what ma? The density of the given liquid. Okay, the reading against the level of liquid touching the tube gives the relative density of the liquid. So in this way, which instrument is working ma? Hydrometer instrument is working. So how can we calibrate this one? So what is mean by calibrate? Okay, so calibrate means what ma? Either this instrument is working properly or correctly. So we have to do the calibration word. Okay, so we may done the calibrations, we will get one conclusion what? This meter is working exactly or perfectly. So with the help of, okay, different methods are there. One is lactometer. Okay, lactometer for measuring the density of milk. Okay, lactometer is measuring the density of the milk. Okay, suppose we may take cream. Okay, second one what ma? Density of the sugar in liquid. Okay, chacmometer. Okay, next one albunometer. Okay, so with the help of these meters we can calibrate this instrument. Okay, so next one lactometer. The same way, lactometer also works in the principle of what ma? Flotations. So what is the advantages or uses of lactometer? Okay, what is the uses of or advantages of the lactometer? Suppose we may mix with lactometer. So what is the uses of lactometer? Either we have to find out what ma? Purity or how much percentage of Which one is present in the milk? Water is present in the milk. So with the help of lactometer we can find out. Okay, the same method, the same construction. Okay, but okay, the value marked from where ma? The lactometer 15 at top to up to bottom 45. Okay, bottom 45. Okay, 15 to 45. Okay, the correct lactometer reading is showing at what degree temperature. Either we can use degree Celsius or degree Fahrenheit. Okay, so in our textbook degree Fahrenheit is given exactly 60 degree Fahrenheit. 60 degree Fahrenheit. Okay, so we may find out the reading. Okay, so we have to maintain the temperature at what ma? 60 degree Fahrenheit. Okay, a lactometer measures the cream content of milk more than the cream. Okay, cream content, water content. With the help of lactometer we can measure. Okay, so next one, the lactometer used in where ma? Where? Which unit? Milk dairies or milk factories. Listen, they are using lactometers. Okay, so next one. Okay, these two are the applications of what ma? Principles of flotation. Next one, buoyancy. Next one, buoyancy. Buoyancy. So what is mean by buoyancy? So if you are taking one lengthy bowl or glass jar, okay, 3/4 you have to fill with water. So we have to take any one of the object, okay. The object weight is maybe less, okay, maybe less, okay. The force is acting in which direction? Okay, not upward direction, downward directions. Okay, here water force is acting in which direction? Upward directions, upward direction. The pressure of these two forces, causes what ma? Okay, the differences, causes what ma? Differences. Okay, that force is called what ma? Buoyant force. Okay, that force is called what ma? Buoyant force. That force is called buoyant force. So what is mean by buoyant force? Buoyant force. Okay, the difference between two forces. Okay, what is mean by pressure? Force divided by area. The pressure causes the difference between the two forces. Pressure causes what ma? The difference between the two forces. Okay, the two forces is called what ma? Buoyant force. Okay, that entire principle is called buoyancy. Okay, so if you are taking any one of the object, okay, we put it into the water, what will happen? Suppose weight is more when compared to water, it will go down. Okay, so that is called zinc. Weight is less, it will float on the surface. Okay, so which object containing less weight when compared to water, that type of objects are called positively buoyant object. Okay, positively buoyant object. Okay, positively buoyant object. Okay, so which object, okay, containing more weight when compared to water, so what will happen? Definitely it will sink in the water. So that type of objects are called negatively buoyant object. Okay, so here, okay, we will take two type of object. One is wood, another one is stone. Okay, can you identify which one is positively buoyant object, which one is negatively buoyant object? So here wood is positively buoyant object, stone is negatively buoyant object. Okay, so based on what ma? Density and flotations. Flotations based on what? Density. So buoyancy based on what? Density. Okay, so can you understood ma? So up to today class is enough. Okay, so remaining headings we will see in the next class. Okay, around 1 page is around bending. So next class I will complete the entire lessons. We will see the evaluations also. Okay, so today homework. Okay, today homework. Okay, you see carefully. Okay, define homework. Okay, define float. The same way define zinc. Okay, next third one. Okay, so in your textbook, okay, in your textbook, okay, 6th Roman letter. Okay, in your textbook, 6th Roman letter, third and fourth question. Third and fourth question. We have to see the textbook. Okay, page number 37. 37. Okay, fourth one, define buoyancy. Define buoyancy. Okay, fifth one, define buoyant force. Define buoyant force. Okay, so these are the today homework. Okay, so thank you children. Remaining part we will see in the next class. Okay, thank you.